Hello, welcome. Let's have a little discussion of the topic ratio, a little introduction. Now, when we talk of ratio, we are only referring to the comparison between two or more similar quantities. The word is similar. If you are comparing two or more similar quantities, you are having a ratio. And we have been using ratio in everyday activities. If for nothing you are able to take tea, you know that for you to be able to appreciate the taste of the tea, the quantity of water must relate with the amount of sugar. If the ratio of sugar and water is not in any preferable ratio, then it means that either you are going to feel too much of the sugar in the water, or you'll be feeling too little of the sugar. So in this case, ratio is applied. The ratio of water and the sugar must be a preferable amount. We've also been preparing rice water. We've preparing rice. If I have 2 cups of rice and certain amount of water, the ratio of rice to water determine whether I'll be getting a rice water at the end of the preparation or I'll be getting a cooked rice. Ratio, right? So ratio is around us. So in this case, ratio can be represented with the symbol this is to. That number is what? Is to. So whatever comes before the column, then whatever comes after. These are the two ratios, two quantities we are comparing. So we can have A is to B. A is to B. If it is a rice, 4 cups, let's just say 4 cups of rice to, let's say, 5 cups of water, so that we can get rice water. But if I want to get, let's say, cooked rice, then 4 cups of rice, let's say 3 cups of water, the ratio must correlate. Now, ratio can also be written as a fraction, as in A is to B could also be written A divided by B. So a ratio, this is a ratio, A is to B. This is also ratio. If I have, let's say, X is to Y, that can also be X divided by Y. You get it, right? So ratio can be in this form and ratio can also be in this form. So ratio is always written in the simplest form. As in, if I want to say that 4 cups of rice is to 2 cups of water. You remember I said similar. If I have this can be written in the simplest form, since it is also a fraction. So this could be written as 4 divided by 2. 4 divided by 2, we can divide both sides by 2. 2 goes here, 2. 2 goes here, 1. Since we are looking for two quantities, it's going to be 2 is to 1. That is the simplest form. We can also write it in this way and divide both sides by 2 and end up getting 2 is to 1. It doesn't matter. All we want is what? It must be in the simplest form. 2. Ratios must be of the same unit. So if, for example, I am asked to express 20 centimeter to, let's say, 4 meters, we are to express this to this as a ratio. You can see these are all measurement in terms of length, but this is in centimeter, this is in what? Meters. So if I want to express the two, I might not be able to just say 20 is to 4. That cannot work because they are dissimilar quantities. The unit of measurement is different. So for me to be able to have what I am looking for, I need to change one of the units into the other. So in this case, I can change meters into centimeters. So that will become 20, let's include a centimeter, is to, if this in centimeters is going to be 4 times 100, that's 400 centimeters. But you remember we mentioned that it's the fraction. Therefore, centimeter divided by centimeter will cancel. So I'll be left with 20 is to 400. In this case, we are saying that it must be in the simplest form. So we look out for a number that we can use to divide both sides. Any number that you think can be a common factor. So I can use 20 dividing itself 1 times. Then 20 will also go into 40 2 times. So we remember that the other 0 that gives us what? 20. So it means that the ratio of 20 centimeters to 4 meters is going to be 1:20. That simply means that if we are comparing any other thing, if I pick 1 centimeter, then it means that I'll be picking what? 20 centimeters. If I'm doing measurement, you know, when we are, those who are carpenters, when they are constructing table, constructing wardrobe, they also have the same ratios so that the table will not bend in a certain manner if they want it to be straight in having equilibrium. So they'll look at the ratio that if the length is 1 centimeter, then it means that the height must be 20 centimeter for it to balance for equilibrium they are looking for. That is all about what? Ratio. So in ratio, always make sure you are comparing two quantities. So we can also have another example. So you have a question like this. There are 20 students in a class, of which 12 are boys and the rest are what? Girls. So find the ratio of girls to boys. Meaning, imagine you want to form a group. You want to form a group in your class. How many, for you to be gender specific or not to be gender biased, you need to have the same number of girls and boys per each group. That is where the ratio comes in. So in this case, we already know total number, which is given as what? 20. We also be given number of boys to be 12. So we need to find number of what? Girls. So since there are only 2 criteria, boys and girls, that sum up to give us 20. If I subtract the 12 from the 20, it gives me the number of girls. Now our ratio that we are looking for is girls is to boys, meaning we are comparing girls to the boys. How many girls do we have? There are 8 of them, and the boys is 12. It must be in the simplest form. Hence, we're looking for a common factor, which could be 2. 2 divide 4. Let's take 4. 4 dividing 8, that will be 2 times. And 4 dividing 12, that will be 3 times. Meaning, in that group, if I pick 2 girls, there should be 3 boys. 2 girls, 3 girls in one group. The next one, 2, 3, 2, 3 in that order. That is how the ratio is going to be done in terms of grouping them. I believe you will get the concept of ratio. In the next episode, we will now to take different aspects of questions that involve the principles of ratio. Thanks for watching. Don't forget to subscribe, share, like, and comment. Bye-bye.